Okay, so in this video, I'm going to teach you how to solve a specific probability problem. This is a very common probability question wherein there is a box. Sometimes it's a bag, sometimes it's a bowl. But in this example, so we use a box in which it contains 6 balls, 1 yellow, 2 green, and 3 red. The scenario is a person picks 2 balls one at a time. Okay, so we can just imagine the scenario in this way. So there is a box, and then inside the box there are 6 balls. Um, one yellow. There's only one yellow. And then we have 2 green, one, and then two, and then there are 3 red. So if the box is covered and you have to pick 2 balls one at a time, you don't know what to get, right? So that's why we say we can compute for the probability for a certain ball. Now from basic probability, where if we just want to find the probability of getting a yellow, we all know that the probability of getting a yellow the probability of getting a yellow is just 1 out of 6, and the probability of getting green or a green just from a single pick, we have 2 greens out of 6 or 1 out of 3. The probability of getting a red is, well, we have 3 reds, and then out of 6 or 1/2. So that's how you get the probability for each color. Now the problem is no longer that simple. What we want to do here is to find the probability. Let's take a look at the first one, that we pick at least one green. So we can just imagine like what are the different combinations of picks that we can have in such a way that there is at least one green. Now some people can do it directly, but for the purpose of explaining the idea in a more detailed way, I'm going to show the solution first using a probability tree. Okay, so we will be making a probability tree. Okay, this is not necessary like in the test you make a probability tree. No, but for the purpose of understanding how some combinations can be obtained, so I'll be showing you the probability tree. Again, remember the scenario is you are going to pick 2 balls one at a time with replacement. So once you get something from the box, you see the color, you have to return that ball again. So meaning the total number of balls is always preserved every time you get a ball from the box. Okay, so if we're going to make 2 picks, that means, so let's say this is our starting point. On the first pick, well, there are just 3 things that can happen. Either you get the yellow, you get the green, or you get the red. That's the probability, right? Or the choices. And we have seen that the probability of getting a yellow is 1 out of 6. So just note down the probability on the branches. And then the green, there are 2 of them. So this is 2 over 6 or 1 over 3. And then for the red, there are 3. So we have 3 over 6 or 1 over 2. And then if we go to the second pick, so remember, after getting a color, you have to return the ball. So suppose you obtain a yellow on the first, and you're going to pick another ball. take note that, again, there are three things that can happen. You get a yellow, you get a green, or you get a red. In the same way that if you will get a green on the first, either you get a yellow on the second, a green on the second, or a red on the second. And if you obtain a red on the first, again, you get a yellow or a green or a red on the second. And the probabilities here are all preserved. 1 over 6, 1 over 3, 1 over 2, 1 over 6, 1 over 3, 1 over 2, 1 over 6, 1 over 3, 1 over 2. So as you can see, it takes some time to make the probability tree. That is why if this is an exam question, then it is no longer suggested to really construct a probability tree. It could be helpful if you don't know what to do, but later on I'll show you a faster way of solving or answering the questions in this probability. Okay, so this is just to show you how some combinations are obtained. Now, pay attention to the probabilities that we have on the second peak. Those probabilities 1, 6, 1/3, and 1/2 were preserved because this is a case of with replacement. So meaning the total number of balls after the first peak is preserved. Because if this is a question on without replacement, that means 1 out of 6 will no longer be 1 out of 6. Meaning to say, if you get a yellow on the first, take note there's only one yellow. And there's no replacement. You're not going to return the yellow. Then that means there's no yellow anymore in the box. Then the probability here will become 0. Right? You understand? And if you get a green, for example, there are 2 greens. The probability of the second green will no longer be 1 over 3. Because there are 2 greens and you got the first green already, you have 1 green left. So 1 out of not 6, but it's 5 because you have taken 1 of the 6 balls, right? Initially you have 6 balls. Once you take 1 ball, then you have 5 remaining. So in that 5, for instance, for the green, if you have taken a green and you want to take another, or if you want to know the chance of getting a green on the second, then you will only have 1 out of 5 and not 1 out of 6 or 2 out of 6. Okay, so that's the idea. And then once you have completed the probability tree, this will be easy now, because what we want is the first question is to pick at least 1 red. Okay, now following your probability tree, if you follow the branches, these are the branches, many branches. If you follow the first, that means you have yellow, right? Yellow, green, yellow, red, green, yellow, green, 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 red, red, yellow, red, green, and finally red, red. So these are all the combinations that we can have. If we count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9. And this follows the rule, the multiplication rule. First pick, you can have 3 of the options. Second pick, 3 of the options, yellow, green, red. Multiplication rule, 3 times 3, the total number of possibility is 3 times 3 equals 9. That is why we have 9 combinations. Okay, now for each combination there is a specific value for their probability. The yellow means getting a yellow and then a yellow and then a yellow. So this is already combined events. So the probability of getting a yellow and a yellow Well, following the tree diagram, or the probability tree rather, that's 1/6 times 1/6. So this yellow is 1/6 times 1/6 equals 1 over 36. Yellow-green, the probability is 1 out of 6 and 1 out of 3, 1 over 18. Just make sure to multiply the fractions properly. Yellow again is 1/6, red is 1/2. See? Do you understand what I'm trying to do here? So 1/6 times 1/2, that's your yellow-red. 1/6 times 1/2 is equal to 1 over 12. Green-yellow. Green is 1/3. Yellow is 1/6. And you have 1 over 18. Green is 1/3. And then 1/3, that's equals 1 over 9. Green-red is 1/3. Red is 1/2. The product of 1/3 and 1/2 is 1/6. Red-yellow, 1/2 times 1/6. This is equal to 1 over 12. 1/2. Red-green, 1/2 times 1/3. 1/2. 1/3 is 1/6. And finally, red-red, 1/2 times 1/2 is equal to 1 over 4. So now we are ready to answer any question. Picks at least one red. How are we going to do that? So find the probability that the person will pick at least one red. So all we have to do is to see or to look for those combinations with at least one red. Yellow, red. Green, red. Red, yellow. Red, green. Red, red. Okay, so those are the 5 cases in which there is at least one red. So that means the answer will be, we need a 1/2, we need the 1/6, 1/2, 1 over 12, 1/6, and then 1 over 12, and then 1 over 6, and then 1 over 4. The sum of these probabilities is equal to the probability that we want. So it's basically 1 over 12 plus 1 over 6 plus 1 over 12 plus 1 over 6 plus 1 over 4. And this will be equal to, so we can use the LCD. It's 12. So 1 plus 2 plus 1 plus 2 plus 3. And this equals 2, 3, 4, 5, 6, 7, 8, 9, 9 over 12. So 9 over 12 is equal to 3 over 4 in its lowest term. So the probability of getting at least one red is 3 out of 4. Okay, so that's how you get the probability. Okay, we have the probability 3, and then we get all the combinations that we need. When I say at least red, we do, or we pick those with an R. Yellow, red, green, red, red, yellow, red, green, and red, red. And the thing about this first question, if you understand how to get at least one red, you can answer at least one green, at least one yellow. Well, we'll look at picks no green. That's a little different. Okay, but you can already answer A and C by understanding the letter B, picks at least one red. Okay? Okay, so let's try to answer picks at least one green so that we could answer letter D, picks no green. And you'll see that there is actually a relationship. Okay, so picking at least one green. So we go back to our probability tree, and then we check which of those combinations has a green. The first one is yellow green, green yellow, green green, green red, red green. Okay, and then we simply take those probabilities, the first being 1 over 18. See, we're just doing the same thing, 1 over 18, and then green green is 1 over 9, green red is 1 over 6, red green is 1 over 6. So the answer is the sum of these probabilities, 1 over 18 plus 1 over 18 plus 1 over 9 plus 1 over 6 plus 1 over 6. LCD, there are many ways to add these fractions. I'm just using the LCD. So 1 plus 1 plus 2 plus 3 plus 3. Summing up, 1 plus 1 is 2, plus 2, 4, plus 3, 7, plus 3, it's 10. 10 out of 18, reduce the lowest term by 2, 5 over 9. So the probability is 5 over 9. Okay, so that's how you answer the probability. Okay, now let's connect it immediately to, because there is a question like, what about, so we know this is to be 5 over 9. We got picks at least one red as 3 over 4. Picks no green. Okay, note that letter A, it says picks at least one green. So it's either you have one of the green and then two greens. That's exactly the opposite of picking no green. So if we will remove all those combinations with at least one green, then what's left with us are the combinations without any green. So if there is a probability of 5 over 9 for getting at least one green, then the complement of 4, which is 4 over 9, is a probability of picking no green, right? Because so out of 9 you can get 5 with at least one green. So the complement 1 minus 5 over 9 is picking no green. Okay, you understand? Or the long way, you go back to your probability and you get those combinations without any green. Like you can have the yellow, 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 red, green, not no green, so red, yellow, and then red, red, and then do the same thing. Okay, but you don't have to do that anymore. You already know the probability of getting at least one green. Remove those. That's 5 over 9, and you have 4 over 9, the probability with picking no green. Okay, and then finally, let's look at picks a green on the first and a red on the second. This is very specific. Picks a green on the first, red on the second, green, red. So we go back to our probability 3. The green, red is located green, red. This is your green, red. And the probability is simply 1 over 6. And that's it. That's how you get the probability, green and then red. Okay, so very easy for the last one. We're not reversing it. It says green red, not red green. That's different. Okay, but if I say getting a green red and I didn't say the order, then it could be a green red or a red green. And if that is the case, we have 1 6 times 2, right? Because you have 1 6 and another 1 6. Okay, but it's very specific. You get a green on the first and then a red on the second. So 1 over 6. Okay. So earlier I said for us to easy understand, we created a probability 3. So what's a faster way of doing this? well, all you have to do is to identify the combinations that you need. Okay, let's go back to our first question. Well, let's apply it to picking at least one yellow because we didn't answer picking at least one yellow yet. Okay, so we know the scenario already. There's one yellow, two green, and three red. We're gonna pick a ball one at a time, and then we with the replacement. And suppose you want to pick at least one yellow. Okay, so suppose we don't know. Of course, because this is another solution, we are not depending on the probability 3 anymore. Okay, so if we want is to pick at least one yellow, remember the colors that we have are yellow, green, and red. So play with the combinations that you want. If you want at least one yellow, you can have yellow yellow, yellow green, yellow red, or you can have red yellow, green yellow. There are 5 of those cases. The only problem with this, if you don't get all the possible combinations, then that's where the mistake can happen. Unlike in the probability 3, it's very clear. Okay, you have a diagram that gives you everything. You cannot miss any of those combinations. Okay, but when you're trying to list down all the possibilities, there is a chance that you might miss, like you forgot there's also a yellow yellow or a yellow green, one of the possible combinations. So make sure that you have all the possible combinations. Now, after listing down all the combinations, we note that the probability of getting a yellow is 1 out of 6, and then the probability of getting a yellow is 1 out of 6, and this is 1 out of 36. So that's the probability of yellow yellow, which is consistent to our tree diagram. See here, that's our 1 over 6 times 1 over 6 equals 1 over 36, yellow yellow. And then we do the same thing. You have yellow green. Probability of getting a yellow is 1 over 6. There are 2 greens, so 2 out of 6 or 1/3 equals 1 over 18. Yellow red is 1 over 6 times red is 3 out of 6, 1/2. This is 1 over 12. And then red yellow is just the reverse, so 1/2 times 1/6 equals 1 over 12. And green yellow is 2 out of 6, which is 1/3 times yellow is 1 out of 6 equals 1 over 18. And then you could do the same thing. The probability, the final probability is the sum of 1 over 36 plus 1 over 18 plus 1 over 12 plus 1 over 12 plus 1 over 18. Okay, and then we get the LCD, that's 36. So 36, the first is 1 plus 36 over 18 is 2 times 1, 2. This is 3, 3, and 2. Adding the numerators, 1, 2, 3, plus 3, 6, plus 3, 9, plus 2, 11. So 11 out of 36. So that's the probability of getting at least one yellow. Okay, so I hope you understand the process. See, we didn't create a probability 3 diagram anymore. You just have to make sure that you have listed all the proper combination. Okay, so that's how you answer questions like this. Okay, a very systematic way is to create a probability 3. Make sure how to make use of the branches. You have to place the probabilities properly, and then in dealing with combinations, that's basically multiplication of probabilities to get the final probability. Okay, so I think That's everything you need for this problem. If you want to see the explanation again, you just have to rewind the video, go to that specific portion of the video to understand it. Okay, so let's just write down all the answers. Picking at least one yellow is 11 over 36, and then picks a green on the first and red on the second. Green on the first and red on the second. Well, that's green and red. We got that to be 1/6. Okay, so 1/6. And just note down so that you can review. Okay, so questions may vary, but the idea will be the same. Some notes, make sure that to check whether this is with replacement or without replacement. Okay, that's how you answer this question. Okay, that's it.